We've got a triangle P here, and we're told that it is reflected in the line x equals -1, and then it is reflected in the line y equals 1. To give triangle Q, we need to describe the single transformation that takes P onto Q. So let's do these two separate reflections first and work out where Q is. So reflection in the line x equals -1. This is the line x equals -1. Everywhere on that line there has an x coordinate of -1. So if I was to reflect shape P in that line, I can see it's 2 squares away from that line. So it's going to be 2 squares away over here. So it's going to look like this. So that is P having been reflected in the line x equals -1. I am now going to reflect that in the line y equals 1. So let's draw the line y equals 1, which is this line. Everywhere on that line has y coordinate 1. So if you reflect this in that line, again, it's 1 square away from that line, so it's going to be 1 square away on the other side. So this point would reflect to here, this point would reflect to here, and it's 4 squares high, so like that. So this here is shape Q. And I now need to think, what's the single transformation that takes P onto Q? Well, I can see this is a rotation, so I'm going to write that down straight away, because its size is the same. The only thing that's changed is its orientation. I think it's 180 degrees. And because it's 180 degrees, I don't need to say the direction, but I do, I don't need to say whether it's clockwise or anti-clockwise because it's the same thing. And I do need to say its centre though. So to figure out the centre of rotation, I'm just going to use a bit of tracing paper. So there's P. I'm going to guess straight away where the two mirror lines intersect. I think that's a sensible guess to begin with. And if I tried that, I'm going to go anti-clockwise here. 180 degrees anti-clockwise, we can see that does work. It is that centre. So the centre is -1, 1. There we go.